All right, I think we are live. Welcome everyone. We'll probably give another maybe couple of minutes or so, and then we can get started. Thank you all for joining us today. Let's see. Hi, Professor Ziya. We'll give it another minute or so, and then we'll get started. Thank you all again. All right, let's go ahead and get started. Good afternoon, everyone. And thank you for joining us for the celebration of our virtual internship in biomedical engineering program here at WPI. This has been an incredible experience, and I'm excited to celebrate the students, the videos, and everyone who supported this program. So first and foremost, I'd like to just say congratulations to all of the students. You all did a fantastic job on the videos, and we are here to really celebrate you. So congratulations on a wonderful, wonderful job. For those of you who do not know me, my name is Ziya. I'm an assistant teaching professor at the Biomedical Engineering Department at WPI. My co-directors are here. We have Professor Solomon Mensah, who's also a professor in the Biomedical Engineering Department at WPI, and Professor Chris Ziya, who is the chair of the department at WPI of the Biomedical Engineering Department. And I'll have them each introduce themselves. So without further ado, I'm actually gonna hand it over to Professor Ziya, who's gonna talk a little bit about why we started this program and the kind of impetus for this. Off to you.
Yeah. I'll first start by saying congratulations to you all. I watched a lot of videos over the last couple of days, and I'm glad to see your some of those names and faces that I saw in the videos. And as you know from the program, Professor Ayobami did the lion's share of the work, and then Professor Mensah also helped tremendously. And I'm glad I got to be part of this. So at WPI, we have over a dozen research labs in BME. Each one provides multiple undergraduate authentic research experiences each summer. And we've even had an NSF funded REU program for about 15 years, not running this summer or last. And that would host about 10 undergrads a year from around the country. Massachusetts is a hub of biotechnology and medical devices. Boston Scientific's about 20 minutes away, their HQ. From Worcester here, J&J is not far, Novartis, Biogen, all within an hour from here. But as you probably know better than anyone, it's still not enough research and engineering internships to cover the need. Even at WPI alone, we have almost 500 undergrads, maybe a hundred of those grads, so maybe 350 that are looking for jobs in the summer between their college years, and that's just not enough. It's even harder for students from our experience from marginalized communities, Black students, Latinx, first generation, any less affluent students don't even know how to, or are not comfortable asking for positions. Often the students who work in the labs are the pushiest ones, the ones that feel like they're entitled to something, and they push enough, and then you say, oh, you're your third time calling me or emailing me, okay, you can work in my lab. But that's not the same for everyone. And a lot of people can't take volunteer positions over the summer. You just need to make money for the year. So add COVID to that. Many labs and universities, WPI included, restrict access for outside students. Industrial internships have rebounded from last year. Well, there was nothing last year, but they haven't rebounded fully. And again, I'm speaking to the choir here, I'm sure. So that's what we set out to provide, some BME themed internship, not really an internship, but an experience with an equal measure of information, these mini lectures, BME research, with project work and professional development. And through our REU program, these are essential, not just get in the lab and do work, but these other wrappers that give the professional experience. And I think you got a lot of that this summer, I really feel. You may not have performed an experiment or created a working prototype, though I saw a lot of people wrapping cardboard things around their leg, great physical prototypes and Arduino boards that actually had blinking lights, and the CAD drawings. Some of these CAD drawings, I can't do what you did, and especially your video presentations were so creative. You did a lot better than I would have done on many of these. And I want you to know that you did the hardest part of design, the needs identification and really getting to what is the real problem is lost on so many engineers, and they just barrel through and make a product that isn't what's really needed by the users. And the ideation phase, where you're actually going through many different ideas of what you could do. Those are really what I think are the hardest and most important parts of the design process. Clearly, you got to build something in the end and have a product for your customer. But if it's the wrong product, it doesn't matter. So I really liked that you really did that, and you proved yourselves much more adept than myself at making videos. So congratulations and kudos to you all. Tremendous effort. I'll turn the mic over to Solomon then.
Thank you very much, Chris. I think you captured majority of the most important things, and just a few things that I would like to add. First of all, you guys have done a fantastic job. You know, for the time frame you have, for even the content of lecture that we delivered, it was just a truncated lecture that we usually give for the whole term here at WPI. But you know, we picked and choose the most important ones that will be relevant to your case, and you guys grabbed that and you really ran with it, and all of you did a fantastic job. You know, looking at the videos and you know, the creativity that was shown was just way above my head. You know, the card drawings, everything was just so fantastic. Today, I think the key thing or the key takeaway is everybody here is a winner. Everybody, each one of you is a winner. And the fact that you've participated in this program speaks to your character and where you're going to go in life. We chose the global health theme because we believe so much in the fact that those design projects gives a lot of constraints that students are not usually used to. And so I'm sure that most of you had to think extremely outside the box in order to come up with something that was truly relevant and that would be impactful. So I will not say much. I just want to thank all of you. For those of you who came to my office hours, it was very nice interacting with you very early in the morning. And for those of you who were not able to, that sent emails to, I hope that I was able to respond to your queries well. Thank you all so much, and hopefully we get to meet some of you in person. I would hand over the mic to Professor Funmi now.
Awesome. Thank you so much. So I just want to again echo what Professor Villiers and Professor Mensah have said. Is you all did a tremendous work, and you all should really be proud of yourselves. The videos were incredible, and you've done the hardest part of the design process. So I hope that you take with you this process and that you use it in your future project work as you continue in your biomedical engineering careers. So I'm going to actually share my screen here. I have a quick presentation just to go over what the program was about for those who don't know, who are not part of the program, and then we'll get into acknowledgements, and then we'll get into the awards. So let me just share my screen here. Bear with me. All right. Again, so we're in the celebration. You've heard from all three of us. So just the program overview for those who are not familiar with this program. We had over 300 students actually participate in this program from all over the world. We had from 54 universities and colleges, from 12 countries, including from India, Malaysia, Ghana, Pakistan, Mexico, I mean, you name it. It was really quite a thrill to be interacting with so many different people from different countries all at the same time. And so we were really, the teams were quite diverse, even in terms of the countries that students were joining from. We had 63% women or non-binary, and then 26% of the participants self-identified as underrepresented minorities, and 47% identified as first-generation students in college. So again, quite a diverse group of students. We really, again, as Professor Villiers mentioned, wanted to open this up and have this accessible to as most diverse of a population as we could. We were really excited to get that. So the program itself was broken up into three parts. We had the professional development portion, which was in collaboration with the SPUDS program, which is the professional development series for undergraduates. This is the summer program. And so they did a lot of the professional development workshops for the students. And then each week we also had a seminar on the design process. So either myself or Professor Mensah talked about the different aspects from the client statement all through to the final design. So this was the weekly lecture that we had for the design seminars, and then the coffee and conversations, which in conversations with the students, actually, this was probably some of their favorite portions, where they got to interact with faculty, biomedical engineering faculty, both at WPI, and actually we had a few outside of WPI as well come join us to talk about the different aspects of biomedical engineering, to talk about being underrepresented in biomedical engineering, and just to really generally talk about their career paths, their challenges and achievements that they've achieved in biomedical engineering. This was a way to lower the barrier between students and professors. To have students have the opportunity to speak with WPI professors, to speak with BME professors in general, to talk about questions that they may not have felt comfortable talking about with their professors, maybe in class. So this was kind of an informal way to introduce and to enhance their experience in biomedical engineering. So the teams, or the students, were actually broken up into different teams. And our theme here was Designs That Matter. As Professor Mensah mentioned, our overall focus was on global health. And so we actually created 10 different projects that was focused on global health with the underlying theme of Designs That Matter. We wanted to really challenge students to not just think about engineering design, biomedical engineering design, but to think about in the context of global health and serving underserved or under-resourced communities. That presents in itself its own challenges. And so the students were divided into 71 teams. You can imagine 71 teams over the past 8 weeks. And these students were incredibly engaged. They met with each other again, virtually, different time zones. We tried to match people up in around the same time zones, but that was part of the challenge. And so they had to work around the different time zones to work on their design projects. And as I hope you have seen in the videos online, they did a fantastic job. So we had projects such as creating a non-invasive way to test diabetes in infants, in newborns. And so they were some teams were challenged to design this new device. Others were looking at filtering lead from drinking water in a sustainable and cost-effective way. Others were looking at using phototherapy to treat infant jaundice in developing countries. So these are just a couple of examples of some of the projects that we had. But again, we would challenge them to think about not only the safety and efficacy of each of these designs, but also the cost and how it can be adapted in whatever countries they were looking at. So I hope you've taken a chance to gotten a chance to look at the videos online. I have the playlist here. This is just an example of one of the videos. But I will post this on the chat, so for those who have not had a chance to take a look. And so please take a look. I mean, I know there are 70 videos, but feel free to browse through and take a look and see if you have some of your favorites. And we'll give out awards later in this celebration. So with that, I'm going to hand it over. I'm going to stop sharing here and hand it over to our students who will tell us a little bit about their experience here in the VIBE program. Yeah, so I'll open it up. And so Enoch, I think Enoch Adelekon is first, and he'll tell us about his experience. Enoch, go for it.
Good afternoon. Can you hear me?
Yes.
Yes, we can hear you.
All right. So I'm Enoch Adelekon, and I'm a rising sophomore biochemistry major at Kathleen University. So to start with, being an international student, I've realized that there are not a lot of opportunities like for international students in STEM. And I was really grateful for WPI, opening this opportunity to a lot of diverse audience, taking international students and people from other countries. During this program, I was able to experience firsthand the biomedical engineering design process and gain insights from professionals in the field, like towards career advancement, towards industry and academia, graduate school, and working in companies. All that, I gained a lot of knowledge and direction from that. And my experience here has not only, taught me like things in BME, but also like it also helped me to shape my career path, my choice of career. Because while I was here, I'd always been passionate about solving problems, but this is I got to gain a first-hand experience of actually designing something that could affect the real world. And it was really interesting. I enjoyed every bit of it, with the setbacks, and everything was just interesting, even with the setbacks, because my team had to rebuild, we had to rebuild our design process and come up with a new design in limited time. So that was also interesting, because it could be interesting in a way, but then it was really interesting. And I also appreciate the freedom we had and the no pressure environment we had while working on the project, because there was no stress about this or what if this isn't good enough or that. It was just have fun with it and come up with something that would work or fit the solution. And I appreciated that. And over my time in VIBE, I've learned one thing about teamwork. To work in a team, you have to be able to trust your teammates, relying on their strengths. And that's what my teammates here at VIBE have shown me, and I really appreciate that. Ultimately, I'd like to say that my experience here has been life-changing in a lot of ways, just career shaping and a lot of things. It's just been really good, and I would like to appreciate everyone who put in work to make the VIBE program what it is. Thank you very much.
Thank you, Enoch. Next, we'll hear from Malaika Chaya.
Namaste or good afternoon, good evening, depending on wherever everyone is. My name is Malaika Chaya, and I am a fourth year biomedical engineering student, minoring in biomaterials at Manipal Institute of Technology, India. And I remember about 2 months ago, I was frantically looking for biomedical related internships online. We just been sent back home from campus because our campus, the cases had just gone crazy. And honestly, I didn't know what to do with my summer. And then a friend of mine actually came across this internship on LinkedIn and then, recommended it to me luckily. And I got it, and I'm really grateful because especially biomedical engineering internships are really scarce in my country. So I'm really grateful that I got this opportunity. And just to highlight a few of the things that I've learned, overall, it's been a really enriching experience. But if I go into the specifics, I really enjoyed the fact that the design process was broken up into phases and explained in great detail, because I was not aware that there is step 1, step 2, step 3, so on and so forth. I just had like a vague idea of how I would go about designing something, but now that I've learned this, I can apply this to future projects, which is something that's really useful that I've learned here. Also, things like the CAD drawings, I had very little, like almost no experience in CAD, and I got Fusion 360, and just by the fact that I had to make a CAD drawing, that kind of forced me to learn a new skill, which is great because I had to learn it on my own. And also communication with diverse team members. One of my team members is the same nationality as me, he's Indian. The other is a South Korean person, and the third is from Bangladesh. And different time zones, just communicating with all of them towards one common goal was a lot of fun. And then just iterating through the process, and then consulting the professors, consulting we consulted an orthopedic doctor as well. So it was just a very novel experience, nothing like anything I'd done before. And what was also very enjoyable was, as Professor Ayobami mentioned, the coffee and conversations. Those were really enlightening because I felt like it was a space where I could ask anything I wanted without being judged. So that's something that I don't think that's the kind of environment that's very easy for people to access on a normal basis. And it's just been so great, and I want to thank Professor Ayobami, Professor Mensa, Professor Billier, and everyone who's been a part of this program. My team, you guys have been great, so thank you so much.
Thank you, Malaika. Next, we have David O.
Hello, my name is David O. I'm a rising junior studying BME at the University of Texas at Austin. First of all, I'd like to thank my mom and dad. They're not watching this, but they do too much for me, so I'm going to mention them whenever I can. Secondly, of course, I'd like to thank the professors, Dr. Ayobami, Dr. Mensa, Dr. Billier for setting this program up. And finally, I'd like to thank my fellow colleagues who participate in the program. Just as honey can't exist with only the bees or only the flowers, this program couldn't work with only great professors or only interested students. It's together, we made this program a success. And the experience I learned from that success is sweeter than honey, I argue. One of the best things I learned about the program was meeting a wide diversity of people, both from professor side and students alike. On one session, I remember y'all invited chairs of BME from Cornell, Boston, Florida, and WPI. And it was just so cool having this many distinguished professionals in the same, the virtual room. However, what made the session great wasn't just the great professionals, but also the students who asked amazing questions. These students were from all around the world, so they asked amazing questions that I could not thought of, and perspectives and insights I could not review alone. This kind of showed like that like this was a kind of team effort from both professors and students alike. Another fun experience was performing the engineering process at a strict timeline. Okay, I lied. The strict timeline was not fun. I drank so much coffee that last week, but it forced me to optimize my own time and communication. The engineering process though, that was fun. Going from some spitballed ideas to the design drawings where it looked like raccoons drew it. To any raccoons watching, I'm sorry about that joke. And from those drawings, making a CAD model, which I can manipulate in 3D space, that was extremely rewarding. I'll be honest though, with how quickly the program was going, I would sometimes get anxious about my video. And then I remember this program isn't for a grade. Like I have a lot of liberty with this, with the problem. So I'm going to experiment with it a bit. And I implemented ideas I normally would be too scared of in my class. And because of that, I was able to push through my anxiety. And I created a video that I'm proud of and happy to talk about. And so from this, I just learned to have fun with my work. This program offered a lot of skills and experience that made it extremely rewarding. The professors always mention that BME is a small world, so meeting the same people again and again is not unusual. And in this case, I hope to meet everyone again and again, even after this program. Thank you.
Thank you, David. Next, we have Ziya.
Hi, everybody. My name is Ziya Singlema. I just want to say, David, that was so funny. I think if bioengineering doesn't work, I think stand-up comedy would be a great career path. But anyways, my name is Ziya. I'm a senior bioengineering student at Washington State University. I would like to thank everybody who made this program possible. And I just want to say this program was very, very inspirational. I wanted to thank every guest speaker that we had. And it was great to see so many women in STEM and talk about their experience so vulnerably. And after talking to so many great professors and so many great women in STEM, I've gained more confidence and didn't feel like I was alone in STEM. And as for the project goes, I also learned to communicate efficiently. I wasn't like Malaika, we weren't across the country, across the world per se, but we were across the country. So with the time difference, we've learned to communicate efficiently. And we've also learned, I would say I've learned the art of delegating. I didn't know how hard it was to like let go and actually delegate our roles. So I've learned that through this project and through working online. And I would like to say I also stepped out of my comfort zone. I think this program made us go venture outside of the United States and outside of the comfort zone we have. So I talked to bioengineers from China, bioengineers from India, and it was great to talk to an actual locals that had their own struggles and talk to them and hear from their side of the perspective. And last thing, when I started this program, I was super clear that I was gonna go to a PhD and I had my whole career planned out. But after talking to great professors, I actually got the clarity that my career, like next step for my career choice wasn't a PhD school. So I wanted to thank everybody who talked, even though they're from academic background, they talked so great about what to expect and how you should approach these if you're not sure. So I want to thank that. And I've also learned many, many great crises that we have and the flaws in global healthcare. I think some of us were kind of walking blindly and felt comfortable just living in the United States, but I was amazed by like the information that we got, and the project opened our eyes to the global healthcare crisis that we're dealing with. And I want to thank everybody, and I have no doubt that all of us will change the world to be a better place. Thank you.
Thank you, Ziya. And last but not least, we have Spencer.
Hi, everyone. Please, can you hear me?
Yes, but you're sideways.
Yes, we can hear you.
Oh, okay. Oh, sorry. My name is Spencer. I'm a third year biomedical engineering student from the
Spencer,
University
your video is sideways. Your video is sideways.
Okay.
Can you straighten your camera?
Is it better?
Perfect.
Okay. Okay, so I'm Spencer Bryan, a third year biomedical engineering student of the University of Ghana. And before the VIBE program, I really didn't have I didn't have a field I was really interested in. I just knew I wanted to do biomedical engineering. I didn't know what field to pursue a career in or what skills to actually learn. But during the VIBE program, especially during the coffee and conversation sessions, I was able to learn a lot from the professors, like what skills are important, what softwares to learn from. And that really helped me because currently I know what I want to do with my life in biomedical engineering. Secondly, the design process. Before the whole design process, I was designing already. We learned CAD and all that really early in school. So I was already designing. I just didn't know what to do with it because I would just be given a project to design maybe a table, for example, and I would design the table. I won't take into consideration which materials were important or which people to take into consideration and all that. But with this program, we designed a bassinet, a phototherapy lamp for infant jaundice. I had to take into consideration the country, the infant, if it was biocompatible, all that. So it made it really stressful, but it was actually really good. And lastly, team skills. I always see myself to be a team player. When it came to this, I think we were the most unfortunate group. But all the three of us were in 3 different continents. So when it comes to time, we are always not around. So we had to actually create a Word document. Then we had to color code. When one person types, maybe 7 hours later, you receive a reply. It was stressful, but at the end of it, it was actually good because we got to network and spoke with different people. It was really nice, and that made everything really, really beautiful. So thank you very much.
Thank you, Spencer.
You're welcome.
And thank you all for sharing all your experiences. This is very helpful for us to know as well. So I'm going to go back to sharing my screen here. I have a few acknowledgements, and let's see. Hopefully you can all see my screen. Perfect. We'd first like to acknowledge the WPI Morgan Teaching and Learning Center. They're the ones that provided us with the Sandbox grant to actually do this program. So without their funding, this program would not exist. So definitely want to acknowledge that they are the ones that kicked this off the ground. So thank you to the Morgan Teaching and Learning Center. Thank you to the WPI BME department as well. They also had funding. They included funding to this program as well. So again, would not be able to kick off the ground without the funding from both the Morgan Teaching and Learning Center and for the Biomedical Engineering Department. So thank you. Thank you to the WPI Summer Professional Development Series for undergraduate, the SPUDS program, specifically Professor Jessica Rosewitz. It was such a pleasure to interact and collaborate with the SPUDS program this summer, and this is where the students had their professional development seminars. So thank you to the SPUDS program and Professor Rosewitz. And also thank you to the Career Development Center. Heidi Morton actually provided a workshop on resume writing to the students. So we thank the Career Development Center for their facilitation and for helping us with this program. As the students have said, and as Professor Ziya and Professor Mensah have also mentioned, this program would not have happened without help from a lot of different people. You see the three of us, and yes, we are the face of the program, but honestly, the behind the scenes, I mean, so many people helped out. So I hope I got everyone. And if I didn't, please, I apologize. But I tried to go through our schedule and just thank everyone. So first and foremost, I thank the BME department, the faculty, WPI, specifically Professor Albrecht, Professor Zhang, Professor G, Professor Coburn, Professor Reidinger, Professor Raleigh, Professor Whittington, Professor Pins, and Professor Umbadi. They all either served as faculty reviewers for the students throughout the summer, or they or some of them did both. Did the coffee and conversation sessions with the students, talking about their career, their research, being underrepresented in biomedical engineering. So thank you all so much for your input. your time, for your effort, for everything that you did for the students. I know it was greatly appreciated. Next, there was a team of students that worked with us as well to get this off the ground. There was a graduate student, undergrad, and actually a high school student. So we have Athenia Jones, who's a PhD student at WPI in the Biomedical Engineering Department, and she helped tremendously with this program. So thank you with the administrative portion of the program. Athenia was the one behind the scenes. Dana Malloy is an undergraduate. She's a rising senior at WPI in biomedical engineering, and she helped with all of the publicity, all of the flyers and everything needed for this program to run. So thank you, Dana. And thank you, Tony, for all your help with the attendance, tracking attendance as well. Again, without these three students, definitely the administrative portion of this program would have been quite difficult. I'd also like to acknowledge and thank Professor Marilyn Vandermeulen from Cornell University, Professor Kristen Switchman from University of Florida, and Professor John White from Boston University, who all came. They're the heads of their respective departments, and they came to speak with the students virtually about the field of biomedical engineering. And I know it was a very enriching experience for the students. So thank you to those professors, and Professor Liz Wayne from Carnegie Mellon University, who joined us to talk about creating videos and communicating your research. And so she was the one that really inspired the students in their video creation. So if you're looking at videos and saying, wow, this is very creative, I think she has a lot to do with that. So thank you, Professor Wayne. And also thank you, Lily Kortner. She graduated recently. She's a rising senior. I'm looking at Professor Ziya. Okay, she's a rising senior, my apologies, in biomedical engineering. And she also came to introduce and to facilitate the workshop on healthcare disparities and ethics in biomedical engineering. So thank you, Lily. We appreciate all your time and effort. I'm hopeful I did not forget anybody, but again, and last but not least, obviously thanking my co-directors, Professor Billy and Professor Mensah. Again, without their advice, without their help, without their assisting students, this program would not be what it is today. And thank you, and thank the students as well for all your efforts. So thank you all. With that, we're gonna go right to, I think, what everyone is waiting for, the awards.
Do we get a drum roll? We should get a drum roll.
Drum roll. So we have several awards. I'm just going to go through them, and then we'll hopefully be able to watch a couple of videos before 1 p.m. So these, for the most liked videos, that was taken actually early this morning. So I know the numbers may have changed, but we took the top 5 at 5:30 a.m. this morning. So the Vibe Award for Sustainability, we were looking for a design that was sustainable, that would was beneficial to the environment. And so the winner of that is Team 70. Their video is entitled Corn Husk Umbilical Cord Clamp. And we're gonna watch their video actually later on. So you'll see a little bit of what their video, their design was all about. So congratulations, Team 70. Honorable mention, Team 14, the portable phototherapy units. And they used recycled medical waste actually to create their design. So congratulations, Team 14. The Vibe Award for Innovation. Again, we're looking at, we're looking for a unique design. We're looking for, something that was kind of out of the box, creative. And so again, this was a decision between myself, Professor Mensah, and Professor Villiers. So the winner of the award for innovation is Team 30, and they worked on infrared light to promote bone healing. So congratulations, Team 30, on your win for the most innovative design. Honorable mention, Team 59, and their video is entitled Salvometer, the new way to test for infant diabetes. And we'll also watch a video from them shortly. Vibe Award for overall video presentation. The winner of this, Team 59, Salvometer, the new way to test for infant diabetes. So congratulations, Team 59. We're gonna watch your video in a second. So congratulations on that. Honorable mentions were Team 22, they were working on the infrared light to promote bone healing. And then Team 27, their video is entitled The Choice Device, Infrared Light to Promote Bone Healing. And Team 48, Sterilizer for West African Midwives. And I encourage you all to take a look at these videos at your leisure on our YouTube page. Vibe Award for Video Creativity. Now we're looking here for videos that were a bit humorous, a bit out of the box, creative, not just our usual PowerPoint presentation. And the winner here is Team 54, Telemedicine App for Ambulatory Care. Congratulations, Team 54. Honorable mentions were Team 25 and Team 41. So congratulations to the honorable mentions as well. Your videos were quite creative. And Team 25 was the Biomed Gals and the Extraordinary Auto Wrap IR. If you're into cartoons, I encourage you to watch that video. And Team 41 was the Wearable Infrared Light. And if you like animations and drawings, actually, I think that was David's video. So feel free to take a look at that. As he said, he did a lot with the art. Thank you, David. And so here I'd like us to watch Team 70's video, which again is the corn husk umbilical cord clamp, and they won the award for sustainability.
The miracle of childbirth is a beautiful process which billions of people across the world will get to experience. Unfortunately, in some parts of Mexico, childbirth can easily turn into a traumatic experience filled with grief and suffering.
In the most heavily impoverished parts of Mexico, wealth, inequality, and the lack of infrastructure plagues the indigenous population.
Women are mandated to give birth in government hospitals, but due to obstetric abuse, violence, language barriers, and lack of hospitals, many women are turning to giving birth at home with the help of a midwife as an alternative. Because those who give birth at home lack access to conventional medical devices, they need an affordable and easy-to-use alternative.
The goal of our research was to develop a technique or product to clamp an umbilical cord that is sterile, affordable, easy to use, and accessible for at-home births in developing countries. More specifically, we wanted to cater towards patients giving birth at home in Mexico.
Upon research, we found that a solution that could support all of the criteria listed in our client statement would be using corn husk to tie the umbilical cord. Corn is one of the largest crops in the world, making it easily accessible for tons of people, and it would come at no additional cost to the patient as it is a byproduct of the crop itself.
The medical use of corn husk has been observed in many parts of developing regions of the world, not just Mexico. For example, in Nigeria, husks are used in malaria treatment. Corn husk exhibits strong antioxidant properties, which was observed in an experiment that used liquid chromatography.
Experiments were conducted where the potential toxic properties of corn husk were tested on mice, but no adverse effects were observed. Thus, the external components of corn husk are safe to use. The affordability, accessibility, and medicinal benefits of corn husk make it an unexpected yet innovative option for umbilical cord clamping in developing countries, and more specifically Mexico.
To prepare the corn husks for this use, the first step is to carefully harvest the husks. Meta-analysis showed that an adequate method for disinfecting the corn husks is to boil them for 10 to 15 minutes. After boiling, a clean dry towel can be used to remove excess water, and the husks can be laid out to air dry. Once the husks are completely dry, they can be bent and crumbled without damage occurring. Choose the fullest husks from your bunch to twist into thin strands. These strands can then be tied around the umbilical cord. Tying is a trusted method for closing off the umbilical cord if it is done tightly enough. Many emergency protocols call for the tying of the cord if a classic plastic clamp is not immediately available. When tying, make sure to pull the corn husk as tight as possible. Corn husks have a tensile strength of about 160 MPa, making them more than strong enough to withstand this kind of force. A double knot is sufficient to keep the husk in place. Experts say it can take up to 3 weeks for an umbilical cord to fall off, and the dried corn husks are able to last much longer than this estimated time frame. The WHO recommends a non-toxic and sterile clamp to keep the babies safe.
We needed to develop an umbilical cord clamp with materials that are easily accessible in Mexico. Corn husk is a feasible option as it is widely available, with Mexico being the largest supplier of corn worldwide.
The overall benefits of using corn husk make it one of the best options for umbilical cord clamping in developing parts of Mexico, where typical plastic clamps are not always available. If you enjoyed watching this video, please consider leaving us a like. We really do appreciate it, and thank you so much for watching.
So congratulations again, Team 70. What a wonderful idea. Oops. There we go. So now on to the big one, the most liked video in the VIBE program. This actually was given to the top 5 videos, the top 5 most liked videos in our playlist. So we're going to award 5 teams with this award. So drum roll, please. The winners are teams 12, battery-powered phototherapy lamp to treat infant jaundice. Team 21, lead filtration device. Team 31, orthopedic wearable with infrared light to stimulate bone healing, which is Project Orwell, as they call themselves. Team 37, orthopedic wearable with infrared light to stimulate bone healing. And Team 59, Salvometer, the new way to test for infant diabetes. Congratulations to all. As we mentioned before, the winners, actually all winners, will receive letters of recommendation from us, the VIBE committee. So congratulations to all of the teams. So as I said, we're gonna watch the Salvometer, Team 59, congratulations again. And here's your video.
You've probably heard of diabetes, but did you know that babies can get it too? 1 in 260,000 infants suffer from diabetes globally, with India having one of the highest rates. Premature babies are most vulnerable. Diabetes is typically tested using blood tests to detect changes in glucose levels. You know from prior experience as a child that these tests can be painful and scary, so you can only imagine how infants feel undergoing these same tests. As Team 59, in the VIBE 2021 internship program at WPI, we strive to change the status quo by designing a painless, non-invasive system to test for diabetes. We researched 4 non-invasive methods and selected the best one. Testing using ISF is expensive, difficult, and involves skin penetration. Newborn infants don't sweat much, so this method wasn't viable, and urine tests are outdated, only accurate for severe diabetes. That leaves saliva as the best option.
So we introduced the Salvometer, a new way to test for infant diabetes using saliva in premature babies. The design is based on a lab-and-chip technology research done in 2017. There are 5 of the many reasons why it's a great device. Number 1, it's painless. There are no needles involved. Number 2, it's non-invasive, only saliva is collected for the testing. Number 3, it's quick. The time taken for the measurement process is a mere 4 minutes. Number 4, it's accurate. The saliva glucose levels are converted to blood glucose levels using a conversion factor obtained by extensive research. Number 5, it's affordable. The product is made with readily available materials and will cost less than $30 for the device itself and no more than $1.50 for one measurement, which is amazing for developing countries like India.
Our design consists of 3 main parts. Saliva is collected in the first part. In the second part, saliva is mixed with an enzyme and then a coloring agent. Finally, glucose concentration is electronically measured and displayed in the third part.
We have designed this pacifier for the collection of saliva. The pacifier has tubing through it, which enables the upward movement of saliva. It is fitted with a syringe at the upper end for manual suction so that the saliva can move up easily.
There are 2 steps to the second part, the pre-treatment and the mixing. The pre-treatment part is based on a chemical reaction using glucose oxidase to convert the glucose in saliva to gluconic acid and hydrogen peroxide.
Saliva is injected through inlet 1, and a mixture of glucose oxidase and HRP are injected through inlet 2. This produces hydrogen peroxide in proportion to the glucose concentration in the pretreatment part. Next, a colorizing agent is injected into inlet 3, which turns the mixture blue in accordance with the concentration of the hydrogen peroxide. The microchannels in the pre-treatment and the mixing parts are designed to increase mixing efficiency by installing obstacles along the path to generate a turbulent flow.
The third and the last part of our design is the display of the blood glucose concentration on the LCD display. For that, let's look into its electronics. A LED is used as a light source which passes the light through our sample containing H2O2. The transmitted light is then detected by a photodiode which is connected to an Arduino Nano, which is then further connected to an LCD display. The whole circuit is powered by a rechargeable lithium battery, and a switch is used only to power the circuit when in use. To display the concentration of blood glucose on the LCD display, we have used Arduino IDE to write our program.
So that's Salvometer. If you enjoyed this video, don't forget to hit the like button below.
So congratulations.
You've probably heard of diabetes.
Team 59, congratulations. I'm going to stop my screen here and just say thank you to all of you. This has been such a wonderful experience, for me, just personally speaking, it has been really great to really meet you all from all the different countries you're from, all the different schools. And it's really been my pleasure to work with you all. And I know that Professor Bilia and Professor Mensah share the same sentiment as well. And I'll let them give brief closing remarks, but I want to say thank you to all of you. Thank you for your efforts. Thank you for your participation. This is an unpaid internship that's virtual, so it's easy to disengage, but you all kept engagement, you all kept your active participation, and you all created wonderful videos. So congratulations, congratulations, congratulations. I know that in terms of wrapping things up, you will receive your certificate of completion via email. And we'll also send you a survey to get your sense of how the VIBE program went. So be on the lookout for that. Keep your eye on your email. And again, I wish you all the best with your future endeavors, with the rest of your summer, and with the upcoming school year. Remain safe and take care. Professor Villiers, go for it.
Thank you, Professor Ayobami. Thank you very much. You did an amazing job. Thank you.
Thank you. And Professor Mensah?
Yeah, I think I share the same sentiments. Thank you so much, Professor Funmi, for doing the heavy lifting here. But I also want to iterate that all of you are winners. So please keep that in mind. Just, we had tremendous people trying to join the program, but you guys were accepting in the program, and then you did your due diligence to get the job done. So all of you are winners. And thank you all so much.
Awesome. So we'll be reaching out to the winners, to the award recipients, and we'll reach out to all of you with follow-ups. So take care, everyone. Happy Friday, and we'll see you. Well, hopefully we'll connect with you on LinkedIn. Keep
in touch.
Yes. Bye, everyone.